All right. Hey, everybody, thank you so much for coming out. My name is Kyle Valaton. I'm the director of Port Labs alongside Tatiana, our team, Sophia, the team at StopWaste, the team at CleanTech Open. This is actually quite a large collaboration. So just want to thank everyone that's made it happen. Let's just kick it off with a round of applause. Thank you all for being here tonight. All right, so a little bit about who we are, what we're doing, why we're here. Port Labs is a co-working space, but we have a little bit different. We focus on innovation, hardware tech, people solving difficult problems. As we know, seeing people face-to-face is important. We offer a way to collaborate, events like these. That's our goal, it's our mission. We're also publicly funded, so the experts, the advisors that work with us are all free to you, the startups, the founders. So we have a kind of unique offering here. If you haven't seen the basement floor, chat with Tatiana. If we're still around, we'll give you a tour, but it's a workshop space, very different from what you see up here. So take a look if you can. So that's a little bit about Port Labs. This event is also sponsored by the Hardware Collective, which Kickstarter. There's a bunch of co-working areas around the Bay Area, Studio 45 and SF, Circuit Launch down on the East Bay. They all had a part in making this happen. But the last set but not least is StopWaste and CleanTech Open. So the folks at those organizations have set up this beautiful panel. Again, thank you, Tatiana.
There she is. Oh, is that you? I am so sorry.
Get that. It could be important. It could be important. No, it's a small community. Yeah. Really is. It's a close-knit community. This is nothing. We do co-working days. We're trying to do different industry topics. If you are an influencer or a leader of a specific industry, we'd love to talk to you about having events in your industry, biotech. We have hardware covered. But just please come to us, talk to us. We love doing this. I see Sam back there. Sam with Zero House Co. Just wanted to do a quick thank you, Sam. If you haven't seen his prototype build, his Zero House, please take a look. He can tell you his whole story, why he's doing it, but come find him. Thank you again for bringing that out. That was super cool. All right, and now finally, let's bring out Matt with StopWaste to give a little about StopWaste and the reasons for this event. Thank you, Matt.
Thanks, Kyle. Thank you, everyone, for coming. Really appreciate it. Exciting to be here. There's free beer. That's rare. That's why I wanted to do the event with Port Labs. I'm Matt. I work with StopWaste, which is the Alameda County Waste Management Authority. We have a lot of different roles in the county in terms of preventing and managing the waste, but I work on the built environment team, and we're really interested in seeing a future with a lot less waste in the building sector, one where we're thinking about diverting upstream waste, but also thinking about ingenious ways of diverting it in the process and, educating a consumer base on a different way of living in homes, maybe a little bit of a healthier, safer and a less wasteful way. So happy to be here and excited to meet anyone that's interested in learning a little bit more about what we do at StopWaste after. So thank you.
All right, can I go ahead and introduce TK? Come on up. So let's have you come over here. If you want to take over that mic, Tatiana, and there you go. That's your mic.
Oh, okay, great. Sorry, it's my first moderating panel, so I'm a little bit flustered. So thank you all for coming. Yes. Ooh. Okay. So thank you all for coming, and I'm with CleanTech Open, and if I can get you to please talk about CleanTech Open. I was so focused on the panel that my brain is basically gone.
Hi everyone, I'm Yu Lee, a volunteer from the CleanTech Open. But first I want to thank Port Labs and StopWaste for organizing this event with us. It's wonderful. We are starting to do these live events with people this year, so really happy to see such a big turnout. And so our organizations have a lot of sustainability objective in common. So it's really great to be able to put things together. I also see some current cohort members from the CleanTech Open and some alumni. The companies are really happy to see you come back to us too. But for those people who have not been going to the CleanTech Open events, let me tell you a little bit about the organization. So we are an accelerator for early stage startup companies. We run a training program every year for about 100 companies, startup companies. We are a national organization, but we're most active in the San Francisco, there's Bay Area here, Los Angeles, Boston, and New York. And our organization is also very much a volunteer-based organization. And they have a number of volunteers here, Martina, Ian, Tatiana, and so on. And I've been a volunteer for 15 years. I've mentored and also helped CleanTech Open in a number of other ways. So I talk about the training program. In the training program, we have a 3-month training program every year and provide them with a kind of a crash course of how to run a startup company. We provide them with dedicated mentor to guide them through the process, learn the material, and help them take the companies forward. So as a matter of fact, we just finished the training for our 2023 program. And in the next few weeks, we're going to be helping them try to polish a pitch that they'll be expecting them to present to potential investor. We also will be running a showcase in October 24th to 26th in conjunction with the Verge, a conference. So all these companies are invited to showcase what they have done and also present their business case to a panel of judges and for fun. And maybe for some of them may actually win some money. So anyway, all of you will be getting an email about this global forum coming up, and hope you can join us at the time. And also help us spread the word to other companies who might be interested in joining our program next year. Next year's application should open in February. Anyway, if you want to have more information, come talk to me later, or Bettina, or Ian in the back, or Tatiana.
It's actually really cool if you get the ticket with us. It's way cheaper to get into the Verge, FYI. So I'm the moderator. My full name is Tatiana, but to make things easier, I just go by TK. So we don't confuse us with the Port Labs. Tatiana, who was the brute force behind creating it here at Port Labs. So we have 4 excellent, very interesting startups here. And we wanted to do a little bit of a poll of the audience to make sure that the event is as useful for you guys as possible. It's hard to do the poll from here. So if we can ask for like, how many here are startups? Okay, not that many. Okay, we have one is like aspiring startup. Okay, you guys should seriously think about applying to CleanTech Open if you're doing this. Oh, you're a part of CleanTech Open. Okay, so you are fully, okay. Okay, know this. Any investors by any chance? Oh, we have investors, thank you. I hope you find guys something you wanna invest in. And how many like cleanly we're just curious people, curious supporting environment people? Oh, well, technically you're not just curious, you're a lawyer, I know you. Okay. So you're fully supporting, okay. So we're assuming that you came because you're interested in sustainability, not just energy. Also, we have a great energy company, but it's a lot of attention to waste and the waste stream and turning waste stream into, or, basically least of an footprint on the planet. And since you guys have excellent long bios, I'll let you introduce yourselves, please.
Sure. Hi, everyone. Happy to be here. My name is Andrew Gillies. I'm the CTO and one of the co-founders of Urban Machine. And at Urban Machine, we're upcycling waste lumber from construction and demolition sites. More or less what this amounts to is getting all the metal fasteners out of the lumber once it's coming out of a building so that we can enter that back into the lumber products industry, maybe turn to various products, everything from furniture to architectural facades, and then hopefully soon structural applications as well.
Hi, everyone. I'm Shivam Dehinwal. First of all, thanks for joining us. Sure. Is this good? All right. Thanks for joining us here. I am part of the new product development team at Salient Energy. We're a zinc ion-based energy storage company. We're making residential energy storage systems as our first product, just like the Tesla Powerwall, but based on a way more safer cell chemistry. We own the cell chemistry. We develop our own cells. We develop our own Powerwall, and we do it right here. This is my home ground, Port Labs. This is where we build it. And I'll move on to the next one.
Hi, Kristina McMillan, CEO and co-founder of Argyle Earth. We take the waste heat off of industrial processes and turn that into clean electricity to be used on site. We're going to be doing that as a service models to lower the barriers to adoption that many manufacturers have in adopting these types of technology.
I'm Steve Barnett, founder and CEO of Soar Optics. We are developing products for the detection of microplastics in water and in other environmental matrices. Our first customers will be drinking water suppliers who, under California regulations, now have to monitor for microplastics. And then we're going to be migrating from there into the remediation companies that are going to cleaning up microplastics because they still need us to tell them how much they started with, how much they ended with.
So let's start with like your company is most cleanly. We're taking the waste, actually, I think Kristina's too, but like seems like a smaller, at this point, a smaller scale. So you take a lot of resources, and your claim is, from what I've seen on your website, is you are doing it on location, using a lot of robotics, you're doing it on location. My only question on your website is it says zero cost. As an engineer, I don't like, it's never zero cost. I mean, it costs something, and it might come from the price of the product, but it's still not zero cost. So if you can talk more about your technology and what you guys do and the use of robotics and.
Sure, yeah. So our current pilot is deployed at a lumberyard up near Napa. So it is a mobile machine. It's our first pilot. The goal of the technology is to be able to deploy it to recycling centers or demolition sites directly. And I'd have to refresh on what the zero cost comes from because yeah, the robot definitely costs money. But yeah, I think the thing that's most compelling about Urban Machine is just such a huge delta between the input material and what we can get once we process it. Because right now, this is a cost to the demolition contractors. They have to pay tipping fees at recycling centers or landfills, and that could be a couple $1,000s for a large truck load. And we can just take that material for free. We just make that disappear for them, and through our process, we upscale that into high quality dimensional lumber, which, if anyone is following the markets, is worth quite a lot of money. So sometimes when we're running the machine, it really feels like a money printing press, because just like every board foot that goes through that thing is just like another dollar on the docket. So it does feel, it's not zero cost, but it's very lucrative.
Yeah, no, I'm all in support of it. I just like, as an engineer, I like seeing numbers. But as a person of San Francisco who sees a lot of stuff dumped on the street, it would be great to have more of the approach that you're doing there. So you guys are not technically doing waste, but you're, well, actually, if it's, then please do elaborate. And I think, but you are definitely cutting the waste stream in terms of both substances and heat, right? And the dangerousness, let's say, in many ways of the production for the batteries.
So from a sustainability point of view, there are two parts to the problem that we solve. Firstly, by storing energy, you're preventing it from getting wasted, right? You're also not using energy that's more expensive. At night, when you cannot generate electricity through your solar systems, you're dependent on the grid. But if you store it during the day, then you're not using extra electricity. Out of reduce, reuse, recycle, I feel like reduce is the best way of doing it, because then you're not deploying any resources, right? Reducing is just like nothing is being used, right? That's the best way of doing it. And that's what we are doing. By storing energy, we're not depending on the grid. We're not depending on conventional resources. We are making you resilient. For example, if there's a forest fire, if there's any event that they have to cut out electricity, you're dependent on yourself. You can transport that electricity to other places that have that system. And thus, you are a microgrid in yourself. You're self-dependent. You get control of your energy. So that's the first part. The second part is, yes, an energy storage device is a sustainable device, but sustainability for us is built into the process. Zinc, we use zinc as our primary material. That's about 100 times more abundant than lithium. Making zinc ion cells costs about 66% less than lithium ion. We don't have to put in setups like a dry room, anode coating room. We don't just deploy those many resources. And as a result, we are overall building sustainability into our process, into our supply chain. It's entirely North America-based supply chain. We don't employ those many resources in transportation. We are taking sustainability not just as a label, but building that into each thing that we make.
Yeah, and what I found also interesting is their electrolytes. Like the first time when I read water-based batteries, I'm like, what exactly do you mean by that? So apparently their electrolytes is water-based.
Yeah, so our electrolyte is one of the biggest part of our IP portfolio. It's water-based. We have a certification that essentially states that if you punch a nail through our cell, it won't catch fire. The worst case is water vapor. We are way more safer than lithium because of the aqueous electrolyte, and zinc being more stable than lithium.
Kristina. Well, the microphone is
Sure. So effectively what we're working on is we look at it as twofold. One is the technical innovation that helps our product work better. And that problem that we're solving is industrial waste heat. Most people don't realize, I mean, we all have stuff that we're wearing or using that is manufactured and it wastes enough heat every day to power 10 million homes just to make these products that we use. And so the problem with that is there are mechanisms today to recapture that heat when it's really high temperature, for example, manufacturing steel, but not when it's very low temperature. And it's far more prolific, low temperature heat in terms of the volume than it is high temperature. And so largely this is a market that's been ignored because the economics have not made sense in the past. So what we've done is developed a technical innovation that makes the economics make sense. And that's one piece that we're working on. But what's also, we believe, just as important is that there are massive adoption hurdles that just make it impractical, even if the technology works, for businesses to adopt. So again, we're focused on manufacturers initially, but a big part of that is most manufacturers are making products like food products or clothing. They're not in the business of trying to figure out how to buy energy equipment. And so we kind of have a mantra that we want to make it stupid easy for them to buy. And so what are they used to buying today? They're used to buying electricity. So we said, great, what if we could deploy our solutions in a way such that all they do is buy the thing they're already used to buying today? So we would deploy our units, own them, maintain them, and just sell the power back to those individual customers at a cost less than what they would be paying, for example, PG&E, which all of us knows quite a bit. And so what it allows us to do is change the dynamic of deploying these types of energy solutions to not be this long CapEx, planning activity in order for them to even consider whether it's good for them. It's meant to be more of a retrofit or a bolt-on type of solution, and they can sort of instantly begin saving operating expense without having to justify CapEx. And so we've had many of these conversations with customers. We're doing feasibility studies, and the question we always get is like, what's the catch? And there really isn't a catch. That's how we deploy it. And it's a very profitable business for us to not just sell the equipment, and that's what most folks don't realize. So to a hardware group here, I would say, be thinking a lot about your business model and how you can change some of those common assumptions that we all have, which is if we build a thing, somebody needs to buy the thing. Is that really the case? Not always. Sometimes there's a better way to get it.
Yeah, but I really love the, making it really obvious, like super obvious, and sustainability actually being a good business decision. So when you're turning your waste into your resource and printing money, yes, that was a beautiful idea. Steven.
So a lot of the early work in microplastics has been more driven by the impacts on human health and from models in animal health, which of course is not necessarily sustainability, but there are other impacts in the environment of microplastics. They impact the bioactivity of plankton in the oceans. They impact carbon capture, and the oceans are not as efficient at capturing the carbon and storing the carbon. So now, that's all related to the activity of microplastics, and as part of that, there are organizations that are working on cleaning up microplastics, improving on microplastics. Problem is we're blind. We can't really even easily find them and see microplastics. And that's where we come in. We're developing methods that are going to be novel, improved, cost-effective, so that when people are doing this cleanup and are improving the environment and are improving the systems that are out there, they'll know how good their systems are working. From a research standpoint, they'll know which ones work well, which ones we don't. So we're a critical component of improving the situation with microplastics in the environment, in our oceans, and in our ecosystems.
Yeah, and I was talking to Steven, and I have to say, it's like from the engineering point of view, the conversation with you was exciting. And from the human point of view, it's like horrifying. I did not realize, no, seriously.
I almost started off by saying TK said I was the bad news guy, so.
Yeah, it's like the good news is we can measure it. The bad news, it's in everything. It affects everything. It's, yes, you can breathe it in. Yes, it will affect your hormones. No, there is nothing you can do about it.
We're all screwed.
Yes. So, but we're all here for innovation, and we're counting on you, supporting, and we're thinking about it, people, that you will go do more technologies and build on, taking all the science and do the measuring and actually go and do the changes. So how do you think your startups fit into like a bigger economy, if like not for obvious things, like we were thinking about doing it more originally, I think focused on materials. So, but like overall fitting it into the whole thing and kind of making it like it's so easy, it's stupid, it's just basically integrating things in.
Yeah, I think it's all these things we're working on, we're trying to affect some sort of system change, which is always going to be difficult because there's sort of entrenched ways of doing things, entrenched businesses, and we're trying to like rewire that network. And I think that's why it's important that you got to look for sort of the easiest wires to plug away at first and show that as an example. Like what you were saying about it, it's like, what's the catch? I think when you're thinking about these early stage hardware startups that have a lot of risk in them, like you have to kind of look at that model, like just a real simple back of the envelope model as a gut check and be like, does this make any sense? And that back of the envelope model really has to be a slam dunk at that early phase because it's only going to be way harder in reality. Like it just is. So if you're penciling something out in the early stage and you're like, oh, maybe this will work if I squint my eyes, it's not going to work. Like it has to be a slam dunk. And I think that's what we have to look for like when we're trying to shift this larger system around, is just like look for these little pockets of possibility and start in and get a toehold there and then just land and expand.
So like when you're saying it's like maybe it will work, it will not, you're thinking more like in terms of economy and logic, right? Because I mean, I could be wrong, but for me as a scientist, like when I'm starting early, it's very often it's like, oh no, maybe it will work.
Yeah, I think there's multiple factors, right? Like there's just, is it physically possible, right? Like at any cost, is it physically possible? That's probably a good place to start. Like, are you like violating some physical laws?
Fair.
But then you can work into the economics of it, and there's that it's going to get complicated because there's also regulatory pressure and evolving systems and customers. But yeah, just kind of like working through the chain of like the important nodes in the system.
So Steven, I think we've talked about you knowing like the policies. Have you looked a lot at how the policies have affected your business, or how you'd like some specific policies or not specific to change to be of more function?
The whole area of microplastics monitoring came about in 2018. The California State Legislature mandated that the California State Water Resources Control Board come up with methods to monitor for microplastics in drinking water. And that led up to a study which took longer than expected because of COVID. We were part of that study. There were about 30 or 40 organizations. And from that came a couple of recommended methods to monitor for microplastics. What came out were methods that are better than doing nothing, but they're also not great. They can be improved on. So far, everything is fine as far as we're concerned. What we have to ensure is that once we come out with what we expect to be a better method, and that the pressures from the other competitors don't try and water down the regulations a bit. So it's more looking forward. We have to make sure that our agencies continue to improve and require the best detection methods possible within a reasonable cost, obviously. So far things have been fine regulatory wise, but we have to keep an eye on that always. And of course, there are always pressures. So,
But in terms of making it like easy, like a slam dunk in terms of like, oh, it's so easy, we want to incorporate, is there any way to make it more of an interest from the consumer to say, I want this?
The consumer demand is gradually going to come about, I believe, especially as more and more studies of the health effects of microplastics come out. I mean, the drinking water suppliers already have to do it. It's going to start to come. Some industrial companies realize they're going to have to start monitoring the effluent from their facilities. There are some companies that already have pretty aggressive programs. And so there will be a public aspect of it that will demand this. But then the other side of it too is, let's face it, a lot of industries will try and take the low road of just, what's the lowest cost method of monitoring? And so part of what we also have to do is get the word out that we are the best method and probably at the same cost as many of the other methods that are out there.
Okay. So I think, certainly when we look at things like the economics or like the policy landscape, again, we use it as a phrase because it's very motivating to us, but stupid easy, which comes back to really understanding the customer. And so we spent a lot of time earlier than most trying to talk to customers in a variety of industries to understand the potential applications and then to really take it that next level, not just from a conversation, but like, how would this actually work?
So what I'm impressed with is their waste stream, thermal waste stream, is like 200 to 400 Fahrenheit. Is that correct?
That's correct.
Which is lower than my oven. Okay, because like if you run your oven at like 400, 450, so do you actually, like how big does your customer even have to be?
Yeah.
How small rather?
Yeah, I mean, we're focused on food manufacturers initially because they operate predominantly in that lower temperature range. And again, what we're trying to do is open up a market that has not been served before. So steel manufacturers, they definitely have a way and a mechanism of recouping some of their heat today. But we want to go for greenfield. We want to open up markets that have not been done before. So we're focused on food because it operates in that lower temperature range. But yeah, it's either boiling water all the way through to baking bread.
So bakeries are your potential.
But from a size perspective, we're looking at like not your mom and pop bakery, but like think of like your regional food processor. And there are a lot of them. There's 40,000 of them in the US. California has the most, more than any other state. We're focused here initially. New York, Washington, Texas, they're everywhere. And a lot of them are in rural communities. So.
Yeah. So if the question is why would people want us and how do the regulatory stuff support us?
And how easy it is for them to be interested in you.
Yeah, sure. So the answer starts with people want us to because they want to build resiliency and they want energy independence. But the truth is nobody cares about resiliency until something goes wrong. Right? Who thinks about the power cut until it happens? Nobody cares about it until it happens. And we cannot sell something based only on sustainability. There have to be other benefits tied to it. In our case, for our commercial clients, there are regulatory benefits connected to it, like the Inflation Reduction Act gives them tax credits, helps them save money. Companies have their carbon neutral targets. Apple says we'll go carbon neutral by 2030. We'll have our own energy independence at this office. How are they going to do it? They want us. They want companies like us who can do it. And then for the regular residential customer, when they have charge of their own energy, then they're not using energy when it's expensive. They're not using energy during the peak hours. They're using the energy that they stored while the sun was out. So they have a bank of energy. That's how they save the money they pay to PG&E. And these are the benefits tied to them. And these are the reasons why they would want to have such a system in their house.
Yeah, but that's like a standard battery, like even standard lithium battery,
Yes,
right?
yes.
So I don't actually know how close you are to the product. Do you have prototypes, so you have like a full product, and compared to like price-wise,
Yep.
let's say to lithium batteries, and size-wise, let's say, can we stick you into a Tesla?
Sure. In terms of price, we're going to match lithium. In terms of volumetric density, we're going to match lithium. In terms of installation process, we're going to match lithium. Where we're going to not, like the only point we're not going to match lithium is weight. Zinc as an element is way more heavier than lithium. Our system's way more than lithium, I acknowledge it. And that's why we are targeting the residential storage, stationary storage. We're not going for cars. You'll not find us in EVs. We're going to target stationary storage. But in terms of performance, in terms of cycle life, we're going to match lithium. To the question that where we are right now, we're already testing our beta systems. Q2 next year, we'll be deploying our pilots. We have done successful alpha testing. I am pumping in modules is a section of the system. I'm pumping in modules each day. I build them each day. So we have proven the technology at a smaller level. We're testing full systems now. We're close to deployment. And yeah, we're very excited about it.
So I actually think I would like to open the floor to the questions. If you don't have questions, I'll come up with something. But to me, if there are any questions in the crowd? Oh, yes.
I was wondering, so this model of owning the equipment, selling the electricity, I know it's really popular for residential customers, but you get industrial customers who are more resistant to that and say, like, oh, we'd rather own the equipment, or is it similar where they like it?
Hold on. Do we need to record? Yes. So is there resistance on the industrial side
Business
to
model.
Yes.
Yeah. So it's a great question.
Owning, I'm sorry, would you like actually repeat the
Sure.
question?
So I think the question was, we see this type of as a service or not owning the equipment common in residential or even consumer models, but not as common necessarily, or the question was, are they resistant on the industrial side? I wouldn't necessarily say they're resistant. I think that it's not what they're used to. And so there are really two models for adopting these types of infrastructure. One is you buy it, you just flat out buy it, and it's CapEx, and you got to justify the payback model, which is usually reserved for smaller things, buying equipment. The second is project finance, which is like, that's a big project with lots of equipment, potentially lots of financing partners involved, lots of longer term construction. Those are just bigger and hairier, and often that involves, it's because they can't just buy a piece of equipment. We aren't necessarily seeing a resistance, they're just not used to it. And so we've talked to a lot of equipment companies out there, and the reality is they're like, we've considered selling as a service, but we just never got around to it. It's a very different business model. I use the analogy, I'm old enough that like I remember when it was like, hey, by the way, software is on-prem or in this thing called the cloud. That was a big deal, like to think about buying software that was not deployed locally on your servers. And it took an evolution for all of us to be like, well, duh. I think that evolution is coming for equipment and for hardware. And we're more used to it now in our personal lives. Like there's more lease to own options or renting options for things that we might have bought in the past. And I think that manufacturers are just going to be slower on that adoption curve, but we're hoping to accelerate that.
Sorry, follow up on that. Two things that came up. Is there a certain number of years that you would have to contract with them? Because I think that's the biggest thing with Prisma, right? Like, sure, you can set it up there, but what happens tomorrow that like, hey, I don't want it anymore, then that's a huge cost.
Yes.
Secondly, I was curious about, are there any concerns from their end on if their needs of electricity can't be met based on how much energy they're producing? So, would they still have to be connected to the grid, as an example, to supply the extra amount that they would need?
Yeah, good question. So two questions. Do you want me to repeat them? Okay. So first question, remind me the first one again. It was years of the contract. So, okay. So first question is minimum term of the contracts so that they don't call tomorrow and rip it out. Second question was around, sorry, this was a little distracting. Second question was around,
The amount of, like, if they had extra,
Is it
or they don't
enough?
have enough.
Yeah. Okay, so is it enough to fulfill their needs? So great questions, both of those. So the first one is absolutely. The reason why we're focused on manufacturers is these are not people who move their businesses often, right? So these are often facilities that are there for 25, 30, 40 years. And so we would sign similar in like residential, PPAs exist for solar. So people are used to things like 10, 15, 20-year contracts. We would definitely sign a minimum contract because to do hardware as a service, you have to fulfill your own internal payback on the equipment. And there has to be sort of enough in there to make it worth. So yes, we will definitely do 10 years as a minimum. And then the second one, in terms of fulfilling their needs, their overall needs of electricity, we actually won't. And so we want them to stay connected to the grid. Again, stupid easy is what we want. So if I ask you to come off the grid, they're going to be very resistant. Like, what? That's a lot of risk on us that they're taking. We don't want that. We want them to feel very comfortable that there's a plan B, plan C. Many of them have storage as well. And so it's all about, the fact is they're most likely not producing enough waste heat to fulfill 100% of their electricity needs, but it's about energy efficiency. I'm spending the money on the gas, 20 to 50% of it is going through the flue. I recoup that to offset my electricity needs, but it may be 25, it may be 50%. I get the rest of it from the grid. And then if we did go down, they have the grid there, the thing they're very used to. So for us, again, it's about the low adoption.
So I actually came up with a question while all this was happening. So Stephen, we talked about you doing the measurements. Is there any, there's a lot of talk about recycling plastic, but it's not actually happening enough. Is there anything that you see that can be done so it is turned into resource before it becomes the microplastics that's like in everything that you have to deal with?
I mean, from that, so in other words, is there anything being done to?
Is it being done? I know we talked about plastics being recycled, but I also heard that it's not actually being done as much as we're all hoping for.
Right. No. I mean, the actual amount of plastic that's recycled is down in like the 10 to 12% range, I believe. 9? Thank you. Okay. And I assume that's the number here. And we know it's a lot lower in Asia. So, and so is that worldwide? Okay. So the number is very low. And the problem, I mean, where microplastics come from is many times you can see plastics, let's say on the ocean or wherever. But then as they're exposed to the sun, plastics get brittle. And if they're in the ocean, waves can come across and allow microplastics to be released. And but from a more general standpoint, I mean, again, the amount of plastic that's recycled is very, very low. And
so is there anything that we can do to turn that waste into money printing?
To turn it into
that's the new tagline for this event, money printing.
That's a good question. I'm sure there is, but it'll be tough because, I mean, plastics are great because they never break down, but plastics are also a problem because they never break down or rarely break down. That's the whole idea of microplastics. Physically, they're very small, but you can do almost everything to them and you're not going to break them down. So from a product reliability standpoint at the front end, they're great. But then from a disposal standpoint and a lifetime of that plastic in our ecosystem, they're very bad.
Blessing and a curse.
Yes.
Okay. We have more? Yes.
Just to tag in on the microphone. I used to work for a nonprofit locally called Japan Society. They have the Japanese Innovation Conference. Can't remember what it's in partnership with an incubator at Stanford. And I believe there are some Japanese companies looking at bioalgae that can process these and then use that. They're trying to build it to a scale that they can actually make batteries out of this process too. So I think it's very far from actualization, how we'd want to see like in a finished end product, but there are some companies internationally that are looking at ways to recapture that plastic waste.
So basically microplastics plus algae, more batteries. Okay, sounds good. Do we have more questions? Yes.
Oh, you're gonna make me run over there? Oh, good. Go, go, go. There's too many cables to be running. Thank you for your patience.
Regarding the zinc ion batteries, so if I'm not mistaken, zinc ion has a lower discharge capacity than lithium ion. So for larger homes or situations where like there's a lot of power demand, how are you guys sort of addressing that issue?
Yep. So actually, we have a proprietary zinc ion technology, which is a Salient invention, and we're going to match lithium ion on the discharge rates. Right now, we are at 1/3 of the discharge rate of lithium. But as we build our energy density, that's volumetric and gravimetric both, we're going to build more juice in our cells, which is what we've been doing. When I joined the company, we were at 100 watt hours per liter. Now we are at 200 watt hours per liter. 2025, we're going to be 300 watt hours per liter. We're constantly improving the technology. There's a big chemistry research team up in Halifax that does it for us. And that's why I say we have total control over the cell. And that's why the whole IP portfolio was using the materials we are using, we are able to get results close to lithium.
So as you're growing, what time in the future is it going to be actually matching lithium on the discharge?
So 2025, we want to test out, prove out our technology fully at a residential level before we go to commercial. The way we are approaching the market is in phases, where we first go to commercial, where we first go to residential, prove out our technology, prove out the safety, go to commercial, go to industrial, and then go to utility scale storage. So 2025 is the first target to give the same results as lithium. Basically, the goal is to develop a drop-in replacement for lithium-ion systems.
Are there any customers that would be interested in your setup, with like zero interest or like minimum interest in discharge rates?
We do have two customers already. One is Viridian, and both of them are sustainable housing community builders. So one is called Viridian and the other one is called Terry Horton. And they're building full housing communities. They want to put our systems in there so that these small societies are energy independent. We already have residential customers on board. We haven't forayed into the commercial or industrial aspects yet, but yeah, we do have two customers.
Andrew, while we're getting the microphone, how many customers are right now you guys are running? Because it sounds like you're fully in action and you have truckloads of wood coming. Can we find any of the objects outside that are built with your?
Yeah. Our products are in the world now. So our customers, there's two sides of our business, right? There's the source, the input, and then there's the output, where the material eventually lands. On the input side, we're partnered with a handful of the large demolition contractors in the Bay Area. Burma is one of our key partners. And on the customer side, we have most of the customers are on the more like boutique sort of architectural furniture design side. We have about
okay, so it's mostly somewhere in the home cool.
Yeah, or it's like architectural facade, that
okay.
sort of thing. So like Corral is one of our key design partners right now. They're using our material in their products, and they're out there in the world right now. So I think you can actually go on their website and see their products designed and built with our material right now. Corral Design.
I had a question about the zinc batteries. You talked about that sustainability was in the chain. So the big question about lithium is recycling. So how does that process work?
Yeah, so we don't use any components. First of all, we don't use any toxic components. Like there are components. Safe fluorine is there in lithium batteries. Our components can be recycled just like right now, you can recycle our batteries just like a AA battery, like a AA zinc battery. You can go to facilities that recycle those batteries. We are also developing our recycling protocols. So you would be able to tear apart a cell, take out the components, recycle the elements. Recycling is a big part that we're building on, that we're based on essentially. You can currently recycle it. It's just that we won't recycle it right now. We are developing our processes, but just like a AA alkaline battery, you can recycle ours.
I just have a simple two-part question for each of you, and thank you for your time and energy moderation. How long have you each been working on your projects, and is it getting easier?
Maybe I'll start. So we're just coming up on the second anniversary of Urban Machines. So we're just about ready to celebrate our second birthday. It's kind of like playing a video game. You like feel like it's getting easier, and then you just get to that next level, and all of a sudden the environment has changed and things are harder again. So it's just like leveling up. You know, each level has a sort of like a villain at the end that you got to tackle. You feel like you've dominated, but then yeah, you're right back in the fray again. I think it'll probably be like that for a while.
I have to say that for a company in sustainability field, 2-year-old and doing that well is like unheard of. It's like super duper wunderkind.
Yeah, we work hard and yeah, we.
Well, it's also a lot of companies in like with CleanTech Open, we have a lot of companies that are very heavy science-based. Like I've seen companies, it's like, we've been in business for 10 years, we're finally getting like great funding and there is attraction. And it's not that they were not working super hard. It just like, it's great. Don't get me wrong, it's really good. It's unheard of.
Salient Energy has been working on the cell chemistry for 6 years, has been working on developing the power wall for 2 years. Is it getting easier? From the cell chemistry, like science, the way it works is sometimes you get big boosts and sometimes you're like, oh, this is entirely the wrong path. We've been doing wrong. We gotta start all over again. So far it's been good. We've had up and downs. From a business point of view, I think as we develop our power wall, we are becoming more and more intelligent in terms of who benefits the most from these systems. Is it the residential customer? Is it the grid scale customer? Is it the commercial? And that's why we've been changing our strategy. Like 1 year ago, we were entirely focused on residential, but now, like that's what we're learning from a business perspective. Now we are more switching towards commercial and industrial and going for gigawatt-hour scale projects. Because once you hit the economies of scale with zinc ion, that's where you realize the maximum value. That's where we save the most. That's where we make the most margins. So in a business sense, we're getting more intelligent. It's getting easier. Science, yes, there are big boosts, and then there are big, not so good events.
So Argyle Earth, we're about 1.5 years into it, but my co-founder and I were working on it, gosh, I can't even remember how long, for as a garage project, like many startups. And so, I mean, does it get any easier? No, but I would agree we're getting smarter. So we're a lot more thoughtful on the narrative and where we're applying ourselves, and especially the customers that we're trying to solve the problem for. So once you have a much clearer understanding of how it's applied, then I feel like we could be more intentional and focused in our execution, particularly on the technical development side. But yeah, no, it's not easier. Someone once told me, like, to do a startup, you have to sort of be prepared. There are no shortcuts, and you're gonna eat nails. So you just kind of have to accept it. There you go. You're gonna eat his nails. And so you just kind of have to assume that's part of it.
For us, the idea that became Soar Optics came about 18 months ago. We had a patent that was submitted for a detection technology, and I remember saying to someone I worked with, we got to figure out what to do with this one day. And then it just hit, like, microplastics. It's the perfect application. So we said, okay, great, we're going to put those two together. And then literally 4 to 6 weeks later, we were in the CleanTech Open. And it was accelerator time. So it was 6 months of just real intense, hard work, thought, refining our business concepts, what makes sense, what doesn't make sense, changing the company name because I was told that the name I chose was really stupid. I was outvoted 3-1. I guess, okay, so. So that was, and from there, we've just been putting the pieces together. It's slower than we wished it was. You know, you call that harder? I guess so, but it's proceeding along nicely. You know, we're going okay. So I wouldn't say harder or easier. It's just slower, but it's always slower. You know, especially when you have to raise funding to get to certain milestones. So, but I think that answers your question, right? Okay.
Thanks. For the representative from, I'm sorry, I didn't catch your name, from Urban Machines, you're talking about kind of initial calculations, you know, they have to really be high margin if things are going to work down the road. But would you say that as we transition from an economy that's been based on the idea of unlimited natural resources to one that requires sustainability, that maybe in that sense things are possibly getting a little easier? Because, you know, in 10 years ago, I don't think there would be much of a market for your company. And in 10 years, I think it'll be a very significant market.
Yeah, so I think it's probably a case-by-case basis. Government's going to play a role in opening up these markets, like it does in a lot of cases. So if you look at something like carbon capture, there's probably going to be like a lot of drive there from government side to open that up beyond companies that are taking on the initiative themselves. For our case, it's really the barrier wasn't an economic barrier, it was mostly a technology barrier that was not allowing this to happen before. There's just been a lot of advances in the robotics and the AI space that make this possible now. I think even a few years ago, this wouldn't have been possible just because of vision, perception, manipulation, AI stack just wasn't there, sensor stack wasn't there to do this. So in our case, it wasn't really a change in the economic landscape, it was a technology landscape shift. But yeah, I think on a market-to-market basis, you're going to see like there's going to be some change, some inflection that's going to make it possible. In some cases, that's going to be regulatory. In some cases, that's going to be an emerging market that all of a sudden needs something new that hasn't been available before. Yeah, case-by-case basis.
So I think we're coming to completion. Yeah, there is also one, well, there's apparently one more question. Well, two more questions. There is one thing that actually I would, well, Ymir go and then I'll say something in conclusion. Well, apparently this person, Kristen is voting for the person.
He's waving his hand.
Thank you. Thank you so much. It's a pleasure to see clean tech companies, especially in the hardware area, because it comes with a bit of challenge. So the value of that I identify for the hardware company usually from TRL2 to between TRL2 to TRL6 level. So my question is, how you guys survive and overcome that value of that stage? That's my first question. And the second question is the Salient energy. As a battery scientist, you guys probably use the zinc metal and the manganese oxide cathode and some water-based electrolyte. So usually scaling to battery is a problem. You know, it comes with challenge. So how would you guys overcome that challenge? You probably use some roll-to-roll coating for your cathode, I would imagine. But how you guys survive with that process? It's such a challenge for the startup companies that I would imagine. Thank you.
Guess we'll start with the second part.
Sorry, yeah.
That's fine.
Yeah, exactly. So to start with, I am not the best person to answer that question.
Oh, okay.
I am not a cell chemistry person, but I can say in terms of sourcing the materials where our supply chain is solely North America based. In terms of processes, there are some processes that are very similar to lithium. There are some that are uniquely ours. The ones that are similar to lithium are easier to scale because the equipment is already set. I really cannot speak about the coating of electrodes. I think that's a question for the Halifax team and the cell chemists, cell scientists on our team.
I just come here with a huge respect. Yeah, I think you guys did a good job because the battery industry, 80% of acquired by the China. So usually it's a huge problem, and especially ordering cathode material, for instance. Unfortunately, in the US, we don't have any material manufacturer, supplier, or even mineral supplier is very lacking. But you have putting a good job with zinc. Zinc is very abundant. And manganese is also very abundant in North America. So yeah, it should be easier.
Yeah.
But yeah, thank you.
I'm sorry, there was a first
The
question.
first question is how all of you guys overcame the first value of that between the technology readiness level 2 to 6, and some companies got government grants to overcome these. So how you guys, in your case, what was the situation? How was your experience?
So in essence, how are we overcoming the hurdles of the hardware development that we need to make? Is that what you're asking?
Basically, design to product launch, let's say, to making actually to getting to MVP.
Okay. So, I mean, the design we have fairly well locked down. We're an optics technology, which can easily be modeled in terms of details of the design to mimic the performance. That does take funding that we are still looking for to get to the MVP. So we're looking to raise funding. We've also submitted some SBIRs. So we've got a little bit of money that we've gotten in. The city where I'm located up in the Sacramento region, Elk Grove, does give also small grants to startups that want to locate in their city. So that'll help as well, assuming we get that, but I think we will. So we're kind of piecing it all together. It's, that's the way you have to do it.
Short answer for us is we're still in the middle. We're still like crawling through the valley. Our strategy is every day is a knife fight. So you live to survive another day. And that can be a variety of things. I'm fortunate enough that my previous role before, I can take on side consulting projects to help fund things. Like, for example, now we're saving up to get a third-party research institute to do a validation study. We're also applying to things like grants, SBIRs. We're building partnerships with labs, but you kind of have to have like a bunch of irons in the fire at once, and it will eventually pop off. Most people give up too soon. You kind of just like, when you don't get that grant, when you don't get that, investor conversation, producing anything, like you just got to keep going one day at a time, every single knife fight, and you just got to recover from it and keep moving.
Eat nails.
Eat nails.
Beautiful. Shall we, round of applause for our panel? Oh, what TK?
I guess this is over. No, actually, I think do we have time or we have to cut?
Oh, no, I was gonna say, definitely go back through the panel and see how people can
Okay.
get more information.
Okay, actually, if we can, because we still have two people to answer the first part of that. Well, I think, both of you, yes.
I can give a short answer to the one you said. The battery world is divided into two parts. There's lithium-based, and there's alt. All the big players, as you said, lithium is monopolized. The big players of the battery world have an eye on the alt technologies. So the way we are funded or the way we cross hurdles is, say, companies like Duracell have interest in our chemistry. They have programs like Duracell Charging the Future. We have grants from them. We have grants from the government. We are well supported by the California Energy Commission. We are well supported by Department of Energy. There are many, many people who want to put in money in alt technologies and bring it to US. And that's what supports us to move forward.
I don't think I have too much to add other than just iterating quickly is super important, because you're just going to make false assumptions, and you need to test your ideas and your concepts against the real world, against reality as quickly as possible. And one of the only ways you can really iterate quickly is by being ruthlessly focused on what you want to learn from each version, each iteration. Because if you try to overload it, if you try to learn too much at once, or if you try to pack in too much detail, you're going to grind to a halt. You're just going to have so many issues. You're going to overload the problem early on. So just being like razor sharp on what the focus is and what you're trying to learn from that specific iteration. Do it as quickly as you possibly can, and then tear it all down and move on to the next one. Yep.
I think it's a great general statement about startups, and I think it's a good place to end. Yes.
Well, beautiful. Well, thank you. Okay, now one round of applause for our panel. Fantastic. I would like to give one final word to Matt at StopWaste. Matt, can you mind coming up and just letting people know where they can find out more, and TK as well?
Yeah, just stopwaste.org. Just check us out. We have a lot of different programs. This is one small little aspect of the work we're doing. So yeah.
So please go to cleantechopen.org. If you are interested in partnering with startups, we do have, maybe not right now, but you can come volunteer, come to the Verge event. We do have weekly, not weekly, monthly sort of get-togethers, but definitely do come to Verge. We have excellent mentors if you'd like to mentor. And if you're like thinking there's somebody here at the startup that I talked to, he's busy. But if you're having a company that can, our definition of clean tech is very wide. If you can show that your startup minimizes the energy footprint, the chemical footprint, like basically if it makes this planet a better, easier place to be, we probably have space for you. Please come volunteer. We have excellent, excellent mentors.
Fantastic. Well, so thank you to everyone. So due to time, we're not going to do the cold intros, but please use the time to stand up, stretch, and continue to meet your friends, colleagues, future co-founders. Thank you again. Thank you, everybody, for this great event.
Thanks.
Thanks, everyone. Yeah, so please get up and enjoy some refreshments and stick around. We'll probably be closing the doors. Hard stop at 9. Thank you so much.
Oh, thanks.